Alright, 3 quick examples here on how to find the discriminant of a quadratic. Alright, first of all, this word right here, discriminant, basically stands for, if we look at the quadratic equation, right, we have negative b plus or minus square root of b squared minus 4ac over 2a. Right, the discriminant is applying exclusively to the radicand underneath the radical symbol. So the discriminant is defined as simply b squared minus 4ac. And this really is kind of like the key, the trigger to understanding how many and what kind of solutions a quadratic has. And by solutions we mean roots, or basically if they're real anyway, how many times the graph crosses the x-axis and where it does. You'll see that sometimes they don't, however. So this is a quadratic, right? Negative 3v squared plus 3v minus 4 equals 0. It's an equation, in fact, and to find the roots of this, the solutions, you, I'm sure, have learned how to factor, right? So you'd go like negative 3v and positive v, and you'd probably like figure out what numbers multiplied by 4, and you'd try to go from there. And that works for a lot of them, right? Especially in algebra class, algebra 2 class. But once you get to quadratics that don't have like the nicest, neatest answers, you're going to have to learn how to use this quadratic formula. And for this video, we're not actually going to use the formula. We're just going to look at the discriminant. And the question is basically going to be, figure out how many and what kind of roots each quadratic has. How many and what kind. And we'll explain what kind. There are basically 2 types in a second here. Alright, so here we go. We need to first understand that this is in the form ax squared plus bx plus c. Or in this case we're using v's, but if you wanted to change that, that would be fine. So av squared plus bv plus c. Right? So the a term is important. We need to bring that out. That's negative 3. The b term is positive 3, and the c term is negative 4. A lot of times the quadratic's not going to start in standard form. If it doesn't, you have to get everything so it looks like this. So the zero's on the right and everything else is on the left in that nice order. In any event, let's find the discriminant. It's defined as b squared minus 4ac, so we take 3 squared minus 4 times a times c. So that's 9. Let's see, positive 12 minus 48. So this is going to be negative 39. Right, so your discriminant is negative 39. Now, what does that mean? When a discriminant is a negative, right? When your discriminant is a negative, we basically have 3 categories. So let's write this down now. If b squared minus 4ac is less than 0, which it is here, then there are 2 imaginary solutions. Right, when you say imaginary, we're talking like complex numbers, right? If the discriminant is positive, then there are 2 real solutions. This is kind of like the most common one that you've probably seen up to this point. And the third scenario, if b squared minus 4ac is exactly 0, then there's kind of a redundant solution. We'll just say that there is 1 real solution. So 2 solutions up here, 2 solutions right here, 1 solution right here. In terms of how these look, if we wanted to draw a quick graph, quick sketch of these, right, these are just very crude Cartesian planes here, but the first one would be kind of like floating above the x-axis or below, but it doesn't cross the x-axis. This one is nice and neat. It crosses the x-axis twice, and this one would be something that would literally touch the x-axis but not go through it and then kind of bounce right back up. Remember, all these can be reflected as well. Alright, so in this case, this is a negative discriminant, so we have 2 imaginary solutions, right? Sometimes you'll see these referred to as complex. All right, in this case, if we wanted to just get a really quick idea of what this graph looked like, and you can figure this out without a calculator. All right, if we have x and y, if I wanted to graph this thing, it's a negative quadratic, so it's going to be reflected down, and it's not going to cross the x-axis, so it's going to look something like this. All right, that's just a basic idea. It's a quadratic reflected down and two complex solutions. All right, number 2. A is -4. So let's go ahead and write that down. A is -4, B is 8, C is -4. So our discriminant is, let's see, 64 minus 4 times -4 times -4. So that's 64 minus 64, that's 0. So when the discriminant is 0, there is one real solution. All right, very quick graph here. This thing is reflected down, and it's going to simply touch the x-axis and bounce right back down. And you can use your graphing calculator to check that. Maybe I'll do that really quickly here. So we go to our graphing calculators and we put in our function. All right, -4. We'll just use x's in our calculator. So we have -4x squared plus 8x minus 4. And we'll graph that, and we'll see that it looks kind of like what I said it looked like, right? We can kind of zoom in here. We'll zoom to enter. And you'll see that it touches the x-axis and just comes right back down. All right, you can see right there. All right, quickly, if we go back up here, it might be a good idea to make this connection. Type this in, right? We have let's clear that out, -3x squared plus 3x minus 4. Let's see if this looks like what it should look like. Let's zoom standard here. Yep, pretty darn close, right? It looks a lot like this green graph over here. It does not cross the x-axis. In that case, you have complex solutions. All right, number 3, last one here. So let's extract our A value, our B value, and our C value. That's +2, -10, +8. So your discriminant is, let's see, +100 minus 4 times 2 times 8. So that's 100 minus, let's see, 3264. So that's +36. And that tells me that there are 2 real solutions. And if I were to graph this thing without using a calculator, of course, I would know that, all right, it's definitely going to be shaped like this because the lead coefficient is positive, and 2 real solutions tell me that it goes through the x-axis and has solutions right there and there. So let's take a look. So y equals, let's clear that out, 2x squared minus 10x plus 8. And we'll graph. See, it looks like that. I should have shifted mine a little to the right, but you get the point, right? Right in here, these 2 spots are where the graph crosses the x-axis twice. All right, so it's kind of a quick study of discriminants, right? There's a lot more that goes into that, and of course, if we actually wanted to find the actual solutions, we would use the quadratic formula.